Okay, so for our first example of constant acceleration, um, we have a particle moves from rest. So I'm just going to highlight that from rest, so that means when it's t equals 0, v equals 0, and also its displacement equals 0, with a constant acceleration reaching a speed of 20 meters per second. So that's a v value in 5 seconds and t value. So find the acceleration and the distance travelled by the particle. Now, as mentioned in the introduction to this lesson, we can use the constant acceleration formulas that are in your textbook, and also you will have seen in physics for those who do physics. But more and more the exams are leaning towards using differential equations to solve these problems. So I'm going to try and do this with differential equations. Okay, let's start with an acceleration equation. Now we know that the acceleration is constant, so let's even just call that acceleration equal to k. So we've got a constant acceleration. Don't know why I chose k, just did. So if I want to find out the velocity, I need to find the integral of k, and I know that this will be with respect to t. So I can then find out that the integral v of t is equal to kt plus c when I anti-differentiate. So right now I have two unknowns, but I also have 2 points that I can use to find those two unknowns. So let's start by substituting in when t equals 0, the velocity equals 0, so that gives me k of 0 plus c has to equal 0, and therefore c equals 0. So now v of t equals kt, and then substituting my second point, when t equals 5, I know that the velocity is equal to 20. So 5k equals 20, so k has to equal 4, and we're working, no, it doesn't have to equal 4, let me get that right. Oh yes it does, sorry, 20 divided by 4, k has to equal 4 meters per second. So we have just found the acceleration. So our acceleration was equal to k, and we know that k is 4 meters per second. So that is part A done. Now the second thing we need to do is we need to find the distance travelled by the particle. So same thing again, we're going to use integration. If I now know that v of t equals 4t, then the displacement with respect to time will be the integral of 4t, and we want to find out what that integral is if it's travelling for 5 seconds. So we're assuming that the distance travelled by the particle is related to this 5 seconds. So when t equals 5 is when we want to find the distance, and we know initially it is 0, and its displacement originally is also 0. Okay, so that gives me an integral equal to 2t squared from 5 to 0 plus 0, which gives me 2 times 25 minus 0 plus 0, which equals 50 meters. So I could use integration here to get my answer of 50 meters, or just for the record, I could have used common sense. If I'm travelling at 4 meters per second, that's the acceleration, and my velocity is, no, forget that last bit. I'm not sure, I got myself confused. I'm not sure what I was going to do there.